Hi y'all, welcome to section 5.8b. We're continuing our discussion about finding the area between two curves. Okay. Today we are going to be using our calculator, so please make sure you have your calculator out and ready to use. Okay. So, two functions, we're finding the area between these two curves. F of x equals this parabola and this linear equation. Okay. Since you have access to your calculator, go ahead and punch those in on your calculator. And if I've punched in my two equations, let's see, graph 1 and graph 2. So if I graph those, you just type them into y1 and y2. Should look something along those lines. It looks like I'm a little bit zoomed in. But hopefully you get the idea. You have the parabola on the bottom, and then the line would be going across. Okay, so let me steal that and use that here. So something along these lines. Zoom, zoom. Okay, so hopefully you can see the region in here is starting here and ending here. Okay, so the first thing we need to do is find those points of intersection. Now, if you have access to your calculator, you do not have to set the two equations equal to each other by hand because you have your calculator. You totally could set them equal to each other and solve, but why do the work if your calculators can do the work for you? Okay, so if you have access to your calculator, you can calculate exactly where those two, where the two curves cross by saying second trace, which is calc, and you're going to be calculating the intersection point, so 5. Okay. Once you've done that, you can ask, it'll say first curve, you say yes, enter. Second curve, it'll automatically pop up to the other curve, you say yes, enter. And then it'll say guess, and you press enter again. It's not actually guessing, it's calculating for you. Okay. So this came over here, you can see it's blinking right there at that dot, and it says at x equals -1 when y equaled 1. So I know that that is -1. Okay. To have it find the other point of intersection, you would need to have it sitting on the screen. So I'm going to need to zoom in or zoom out so that I can actually see that. Move the little blinky thing over to that, closer to that point of intersection, and calculate that one. Okay. I'm trying to save time today, so I'm not going to do that second point of intersection. You should have gotten 4 when you did that one. Okay. So you were starting at -1 and ending at 4. So you know that your setup for the area will be the integral from -1 to 4. And remember, in terms of like big idea here, this is going to be the top curve minus whatever the bottom curve was with respect to x. Okay, all of our problems so far have been at vertical in orientation. So if we think about all of these, anywhere that we took a little slice here, be top minus bottom would give us the height in there. And then the thickness would be a change in x, and we're going to add all of those up. So in this case, if they've called the two functions f of x and g of x, you don't actually have to rewrite them right here. You can just name them f of x and g of x. So in this case, is f of x or is g of x on top? You at home, hopefully you're answering. This is g of x, right? So this would be g of x minus f of x in terms of your setup. Okay. Now, this is what I was giving some of you a hard time in class today. Some of you just did not write this on your paper. You have to write this on your paper. This is the setup. Okay. And now, because you have access to your calculator, literally you don't have to do anything else by hand. You grab your calculator and you do the rest on your calculator. Okay. So, what I tend to do on these problems is like what I had showed you is type in the two equations. No, I've typed in all of the equations for the entire homework set, so I don't have to type it all in. But I have them here in y1 and y2, so if you want to do the same thing. Now notice in my equation though, g of x came first, and that's my second equation. And then y1 was my f of x, so that's will be the second equation. Okay, so I am going to need to tell the calculator to integrate these two equations from -1 to 4, but I'm integrating the y2 minus y1. Okay, so try and follow along the steps that you're going to type to, let me clear that out. To get the integral, you press math 9. So you go math 9, and that says function integrate. So what are you integrating? Again, you are integrating g of x minus f of x. And since you already have these typed into y2 and y1, okay, you can just tell the calculator to integrate y2 minus y1. And so we use the vars button. Vars stands for variables. So you press vars, go over to y vars, and then always functions. You just press enter for function. And now you need to just, figure out where you had typed in your equation. So my first thing that I'm integrating was y2, so I need to pick 2. y2, and I need to minus y1. So I'm going to say minus vars, y vars, function yes, y1. So that's my integral. I'm integrating y2 minus y1. If the equations were shorter and quicker, you could type them in right there if you'd like, and you don't have to do the y, the vars. But realize a lot of times you're going to be graphing anyway, so you will have already typed them in, so you might as well just use the y1 and the y2. Okay? So we're integrating y2 minus y1, and then comma. We always say with respect to x, so then it's always x. Comma, starting at, comma, ending at. So in this case, we were starting at -1, comma, ending at 4. And then end your parentheses, and when you press equals, that should give you your solution. Okay? So 20.833 is the final answer. And if we talk about the area of this, we can say the area equals, and then the area equals. What did it just say? 20.833. Okay, so 20.833. And remember on the AP test, it's either truncated or rounded. So they would accept 0.833 or 0.833 since rounded or truncated is the same. So that would be the only acceptable answer. Okay. In terms of setup and what you have to write on your page, this is all you would have to write down for the AP test. You don't have to draw a picture. You don't have to, show all the strips. But remember, we're going to eventually be taking areas like this and rotating them around axes. So the better you get at understanding it all, the better you're going to be in the end. Okay? So this should hopefully feel a lot easier because it's just the same idea, but you're just punching into your calculator. Okay? So if you guys are ready to try number 2 on your own, you can go ahead and try it. Although I know when I took this problem, it's an old AP problem, they had actually provided these 2 equations and also the graph, so you didn't have to figure out exactly which area they meant. Okay? So let's pretend that they had given you this and they also had given you this picture because they had actually graphed it for you. So hopefully we're clear that that is the sinusoidal function. So there's f of x. And then x cubed minus 4x, it's a nice cubic function. And it happens to cross exactly right there and exactly right there. And actually in this interval it looks kind of parabolic. It's just the Vizhumi stuff. Okay. So we are trying to find the area of all of this stuff right here. Okay. We want to know exactly how much area is sitting in between these 2 curves. Okay. So hopefully we can see, and you can type that into your calculator and graph it all if you need to. It just gets a little messy with all of the various areas. Okay. But if you're going to look at this in your calculator, you can find those points of intersection. Okay, again, second trace, which is calc, and solve. Like this is a perfect example. They could not give you this without your calculator, because if you set sine of pi x equal to x cubed minus 4x and tried to solve, you'd be stuck. You couldn't figure out what the values are. Okay, but if you do that whole second trace calc, this ends up being exactly 0, and this ends up being exactly 2. Okay, and again, if you need more help with that in class, I will definitely help you out with that tomorrow. So we're going to take the integral from 0 to 2, and over here we're going to think about how long, if I just randomly took a slice in here and I sliced it, how long one of those slices would be. How long this slice would be. Okay, so from top to bottom. From top to bottom. So in this case, it truly is the sinusoidal curve, f of x, and we'd be subtracting g of x. So in terms of your setup here, you could just write f of x minus g of x. Okay. And then if you have them punched into your calculator, you can just tell the calculator to calculate it for you. Because I had all of my equations typed in there, I'm going to unhighlight my y1 and y2. Oh, if I wanted to graph, I would have done that. But so y3 is my sine, and y4 is my cubic function. Okay, so this will be y3 minus y4. So if I go to calculate that, and I actually did this on my own, you can check and see if you get the same answer. Looks like you should get a nice pretty 4 if you do it. So you should get a value of 4 in the end. Okay. If you typed it into your calculator and looked at the graph, it was pretty messy. There were several bounded regions. And so that's when I looked back at the original AP problem, and I remembered that they had provided the graph for you, so that there wasn't a miscommunication about which area you were trying to find. Okay. So 4 was the final answer there, and it was exactly 4, which is kind of cool. You didn't have to worry about rounding or anything. All right, I'm trying to make this fast, maybe the fastest ever. F of x equals natural log of x. So I do expect you to know how to graph that without a calculator. So natural log of x is a nice Vizhun, something along those lines. And critical point is that the natural log of 1 equals 0. So right there is our 1. And this is always an interesting one. If you were to try to type this in on your calculator, we could type in natural log of x, but x equals 4. Realize x equals 4 is a nice vertical line. And your calculators in function notation will not, graph a vertical line because it's not a function. Okay, so if you have x equals a value, you have to know that you are creating your own, you have to know what that looks like. So if x equals 4, here's 4, so that is a nice vertical line through 4. Okay. Now realize if we just left it with natural log of x and x equals 4, we would not have a bounded area. So we just have these point of intersection, but they would never cross again, so we wouldn't have a bounded area. So they must have told us specifically in here which area to use. So it told us that we were going to be in the first quadrant, bounded by those two. So if we're in the first quadrant, we must be looking at this area in here. Okay. So this one's a little bit different in that you basically already know the points of intersection. You don't need to calculate them or figure those out at all, because you're starting here at 1 and you're ending here at 4. So I already know I'm going to have the integral from 1 to 4. Okay, and then if you check this out, if you're going top minus bottom, top minus bottom, top minus bottom, you're constantly starting with the natural log of x, and you're going down to the x-axis. Natural log of x down to the x-axis. So that distance will just be the natural log of x. It's really like natural log of x minus 0. So if you want to be consistent, top minus bottom, that would have been natural log of x minus 0, or just f of x minus 0. So that would be your setup. I did not calculate this one, so let's go ahead and do this. We're going to be integrating basically natural log of x from 1 to 4. By the way, you could not do this by hand. You do not know, nor will you ever know, the integral of natural log of x. Okay? So you're not responsible for that, so you do not need to worry about that. Okay? So if I go in here to my blank screen, I would just say math 9, that's function integrate. I'm going to go ahead and just type it just as it sits right here, so I'm going to integrate natural log of x. So natural log of x, and I can write minus 0 just to be consistent, comma with respect to x, comma going from 1, comma to 4, equals. Go to. So if you ever get an error message, you know that you can go to the error. Let's see what I did wrong. Oh, put 2 commas, so let's delete that guy and try again. And we're left with 2.54, 2.545. Right, so 2.545 would be the only acceptable answer for the area of this region. Okay. All right, y'all. Hope that made sense. We'll see you tomorrow.